changes across energy efficiency, decarbonization, quality, health and safety, environmental management system. He currently advises the organization on strategies to reduce energy consumption, lower carbon footprints, and advance sustainability goals. He has been recognized as on LinkedIn platform as the top 1% in his field. His expertise include developing policy development, renewable energy integration, reduction of carbon footprints practices. He is a passionate educator and advocate in his field. Dr. Mohamed, he's lectured in many Egyptian universities for sustainability and energy saving. He's also the author of the Arabic language book, Sustainable Development, the Past, the Present, and the Future, offering in this book practical guidance on sustainable living and businesses. Without further ado, I will just give the floor for Dr. Mohamed to start his presentation and thank him again for accepting our invitation. The floor is yours, Dr. Mohamed.
Thank you so much, Yousef. Thank you, Engineer Khaled. I am really glad to be here with you today, and thanks for the invitation. Today we are going to discuss one of the most significant topic, I believe, in the world of energy and industry in general, which is decarbonization. By the end of this webinar, we would discuss the meaning of decarbonization and the different means to achieve decarbonization, and also the methodologies to standardize the decarbonization process. So please excuse me. I will share the presentation from my side, and also I will close the camera in order to prevent any disturbance that may occur during the presentation. Okay. And of course, if you have any question, you can drop it in the chat section. And after the presentation, I will go through with all of your questions and comments. I think now you can see my screen. Engineer Khaled, can you give me
not yet, Doctor, not yet.
Not
yet. It will appear now, inshallah.
Not yet. Okay.
Maybe it takes a bit time. Not yet. For me, I'll not see yet.
I can. It's not.
You can see?
Yet. No.
Yeah. Share window, Doctor. Share the window itself, or share the presentation itself.
Okay, I will share it. I will share the screen.
Yeah, then you choose the file. Thank you.
I think now you can see the screen.
It will come, inshallah, because it may be some delay with the network. Doctor, you can share the window, open the presentation, and share the window.
Yes, already shared the screen.
Yeah.
Okay, I will try again.
Yes.
Sorry for any inconvenience. And now not yet also?
Not yet. It will. It takes a bit of time. Maybe. Yeah. Now is okay. Now you can see.
Now you can see the screen, right?
Yeah. Yes. Everyone can see the
And
screen.
you can
You
see,
can comment on the chat.
and you can see it as full screen, right?
Yes, and full screen. Yeah, can you make it full screen? Yeah. Yeah, now it's full screen. Now it's full screen, Doctor.
Now it's full screen, and you
It's
can
clear.
see, the slide. Yes. Okay. Okay. Wonderful. Okay. So let's get started. Okay. So now we are going to discuss the decarbonization. Okay. And when we are going to discuss decarbonization, actually, we need first to look into a very significant figure related to the global greenhouse gas emissions in
Excuse me.
2024.
Yes, yes,
I
yes.
cannot see the screen. I think you need to turn on the camera.
Not about camera. It is like sharing the file. The file itself. For me, I see. Anyone else cannot see? Is Mr. Stephen is writing? Can you see?
Yes, it's clear.
I can see.
I can see.
It's clear
Okay.
for me.
Okay. Now, Mr. Stephen is comment and Madam Ajaya that it's not clear. I can see some can see, some can't see. Anyway, we will just try again. Who cannot see the screen? He can log in again, or just check if you access from your iPhone, of your phone, or from the laptop, whatever is. But some are showing it's clear. Only I think some or few cannot see it. Showing now? Okay. Some are showing now and some not seeing. Okay, go ahead, doctor. We will see you after a moment. If it's any issue, we can just wait for the response.
Okay. So
Thank you.
so if we look at to the data in 2024, the global greenhouse gas emissions have reached 53.2 gigatons of CO2 equivalent. And actually, this is an alarm because this number represents 1.3% increase over the previous years. So we are not just failing to decline, but actually we are actively accelerating in the wrong direction. So the main question that will derive us will be, what are the needed strategies that we need to implement across several sectors in order to reduce these greenhouse gas emissions. And this reduction actually only occurred through a fundamental transformation in how our industrial sector produce and consume energy. So this is no longer an environmental issue, but it's a cornerstone of the modern industrial strategy. In this webinar, we will move from the why to how, okay? And we will explore the different tiers, let's say, and the strategic pathways that will allow industries to navigate successfully the decarbonization process. Okay, so let's be precise and formally define our terms. When we speak of the decarbonization imperative, we are referring to a critical global objective that's fundamental to both environmental sustainability and long-term economic resilience. In the industrial context, our definition is specific. It is the systematic process of reducing CO2 as a representation for the greenhouse gas resulting from manufacturing, processing of our industrial activities. So this is not a vague aspiration. It's a structured goal that aligns perfectly with established energy management standards, most notably the ISO 50001, where the entire purpose of standard like ISO 50001 is to provide a structured approach to improving energy performance, which directly contributes to reducing global warming. And this process involves a combination of enhancing efficiency,
Dr. Mohammed, you have been muted.
oh, okay. Okay, this is maybe a mistake. Okay, so let's very be clear about the scale and the timeline of this challenge. Actually, these are not random numbers. These are the targets defined by the international climate agreements, such as the Paris Agreement. And for the Paris Agreement goal, the goal is to limit global warming to 1.5 degrees Celsius. To have any chance of meeting this, the science says that we must cut global greenhouse gas emissions by approximately 43% by the year of 2030. Comparing or using the 2019 levels as our baseline. The final target here, or our end goal, is to achieve net zero emissions by 2050. Meeting this ambitious target actually requires a concentrated and accelerated efforts, particularly from the energy-intensive industries. And the timeline is tight, and the work is substantial and non-negotiable, as we will see right now. So this brings us to the industrial sector. Specifically, why this intense focus? Because primary the pursuit of decarbonization is also a driver of multifaceted business benefits. This is not just an opportunity. How is this is an opportunity? First, we have the enhanced competitiveness. This is the business case. Efficient energy use is a key factor for companies to remain competitive. Through optimizing energy performance, businesses directly lower operating costs and also reduce their exposure to volatile energy prices, and also strengthen their market position by appealing to environmentally conscious customers and ESG-focused investors. Second, the sustainable development. Here, our efforts are aligned with the three foundational pillars of sustainable development, of economic growth, social inclusion, and environmental improvement and sustainability. And sustainable development here is a holistic approach that fosters a resilient and equitable future. The third is the regulatory. Now we have many regulations and regulatory frameworks that actually establish clear standards that compel industries to reduce greenhouse gas emissions and pollution. And decarbonization here acts as catalyst for technological innovation that encourages the development of clear, efficient processes and equipment. Okay, so how do we begin to tackle a challenge of this magnitude? The key answer here is to understand that there is no single solution. And we need logical, integrated strategy. And we will call this integrated logical strategies the tiered framework for decarbonization. The tiered framework for decarbonization. It means that we will have different tiers, or let's say different layers for achieving the decarbonization. As we will see now, we will have the tier 1, and we will have the tier 2 and tier 3. Okay, let's start with the tier 1, energy efficiency. Energy efficiency, and also we call it in the context of energy and decarbonization in general, the first fairway, because it is the most important and most cost-effective means for achieving sustainable energy system. As we can see, every unit of energy is a unit that does not require new renewable generation or carbon management. This is the cornerstone of any credible strategy. We can break this tier down into 3 core components. The first component is to implement the energy management system, and here this is the high-level framework. And by adopting a standard like ISO 50001, which we will discuss with a little bit of details later, we can create a robust structure for continuous improvement driven by management commitment and the tracking of energy performance indicator. Also, we need a framework for process optimization. And here we have, or we need the different engineering techniques. And this process optimization actually will analyze all the different means of energy consumptions, like heat, for example, and how the energy flows across the different processes in order to find the optimal arrangement of different energy streams, and to design the significant energy uses in a network that ensure no loss in our processes. And thirdly, we have the role of technologies like the waste heat recovery. And in this technology, we capture the energy, or we capture the heat that would otherwise just vented into the atmosphere. And this technique or this energy could be available at high, medium, or low range temperature. And the key technologies here is to utilize this energy, whatever to preheat water, for example, or to preheat air, or to use it as a source for power generation. So here, with a little bit of details into the tier 1, we can tackle the inefficiencies with the fastest paybacks in different applications, starting from, for example, from the steam traps, okay, where we can actually recover from 20 to 30% of our steams, okay, and this could be achieved through a routine diagnostic and maintenance program. Also, we have the industrial, we have the insulation, okay, and also here insulation could be a significant aspect for improving the energy efficiency. And we have technologies like the variable frequency drives, which can be installed on pumps and fans in order to make some sort of matching between the motor speed and load. And also we have the compressed air in order to prevent the and to cure the leaks that may be present in our system. The second tier is related to substituting the carbon-intensive fossil fuel with other sources or carriers of energy like the renewables and low-carbon alternatives. A primary pathway here is process electrification, and this means replacing equipment that directly burns fossil fuel like a gas fire boiler with technologies powered by electricity. And also, this strategy is not only effective if that electricity comes from a clean supply, and this brings us to the main challenge, the intermittency of the renewable energy. Solar and wind are not available 24/7, and addressing this challenge actually requires effective grid integration and crucially the deployment of energy storage solutions like batteries to ensure a reliable supply from energy. And when we look at the key renewable sources for industry, we can group them into three main categories. The solar energy, and this has two primary applications. First, the solar photovoltaics or PV, which are the technologies used through panels, which all of us may see them on the rooftops, and they can generate clean electricity for direct use. And also we have the concentrated solar power, which use mirrors to concentrate sunlight and can generate the high temperature process steam needed for many industrial applications. And we have also another type of the renewable energy, the wind energy. And this involves using the larger scale, whatever onshore or onshore turbines that generate bulk electricity for the grid. And also we have the bioenergy, which is the process of using organic materials or organic matter by different means, such as the direct combustion, like wood waste or sugarcane residue, to produce heat or steam. The third tier is related to advanced carbon management. And here we have industries which we call hard-to-abate industries, like the cement, steel, petrochemicals. In these industries, efficiency and electrification alone are not insufficient or are not inefficient, because emissions are here inherent in their chemical process, and they require extremely high temperature heat. So tier 3 comes to address these residual emissions through applications of different technologies and different means to tackle these residual emissions. The first mean is through green hydrogen. Green hydrogen, it's a clean energy carrier produced through water electrolysis, powered by renewable electricity. And here, this green hydrogen can be used as a source for high temperature heat, or sometimes can be used as a clean chemical feedstock. The second mean for tier 3 is through the CCUS, or carbon capture, utilization, and storage. And this is a group of technologies that capture the CO2 emissions from the point sources or from the sources of generations, like the factory smokestack, for example, before CO2 released into the atmosphere. These technologies capture the CO2, and then this CO2 can be stored permanently in the deep geological formations, and this is the section of storage, or can be utilized. And this brings us to the e-fuels or electric fuels, or the technology called Power-to-X. And this is a key example for utilization of the captured CO2, where we combined it with green hydrogen in order to produce several other components like the e-methanol or electric methanol or low carbon methanol, and this will close the carbon loop. Also, we have within the boundaries of tier 3, there is a special and critical category. We call it the negative emissions technologies. And the most prominent example here is bioenergy carbon capture and storage, or BECCS. This is a fundamentally different concept, and this pathway actively removes the CO2 from the atmosphere, and it works in 3 distinct concepts. Step 1, we have the biomass in the form of trees, crops, absorbs atmospheric CO2. And we have the step 2, this biomass is then used to generate energy in the form of heat or power. And the step 3 here, the CO2 emissions from this energy conversion process are then captured and permanently stored in the deep geological formation. So by combining biological carbon removal with geological storage, BECCS achieves a net reduction of CO2 in the atmosphere. And this is one of the essential tools for addressing the difficult to abate emissions and completing the decarbonization journey. Okay, so in the previous part, we discussed the different tiers of achieving decarbonization through tier 1 from the energy efficiency, tier 2 from electrification and increase the integration of renewable energy, and tier 3 through advanced carbon management, whatever through green hydrogen, carbon capture, utilization and storage, or BECCS, bioenergy, carbon capture and storage. Now, let's turn into how can we standardize the decarbonization process. In order to standardize the decarbonization process, it's not a compliance checklist, but it's a strategic guide. We need a strategic guide. We need a strategic and standard that we can follow in order to make our process credible and reliable. And the first standard here that will achieve this standardization of decarbonization process is through implementing the ISO 50001. So what is ISO 50001 or ISO 50001? The main primary goal of ISO 50001 is to enable organizations to achieve continual improvement in their performance. And this will include enhancing the efficiency and reducing the operational costs. The ISO 50001 is built on the famous BDCA cycle, or BDCA, Plan, Do, Check, Act methodology. And this is the foundational concept for all modern ISO management system, and it ensures that our energy management system is not a static, standalone system, but it's a dynamic and can be easily integrated with other management systems like the ISO 14001 of the environment. And this will bring us to the strategic imperative. Why do this? All of this. The business case of implementing the ISO 50001 is built on several key benefits. First one is the sustained cost reduction through systematically identifying and acting on the energy saving opportunities. Also through enhancing the regulatory compliance and reducing the environmental impact since any reduction in the energy consumption has a direct positive measurable correlation with lower carbon footprint. And it will enhance the corporate reputation and eventually will improve the organizational engagement to show that our management is visibly committed towards the sustainability across all levels. So the Bedica cycle here is the engine that drives this entire system. We plan by establishing the strategy, the policy, and the objectives. We do by implementing the plan, allocating resources, and managing operations. We check by monitoring, measuring, and analyzing our performance against those objectives. And finally, we act by taking actions to correct non-conformities and derive continual improvement. Okay, so everything begins with plan. And here it starts with the leadership. Through unwavering commitment from top management to drive the energy management system effectiveness. The second step is the energy review. Energy review, it is the systematic assessment of our current and past energy performance. The key output here is to identify what we call the SEUs, or the significant energy uses, that can be facilities, equipment, processes that account for the substantial energy consumption. And then we have the review. We establish the metrics. This could include our energy baseline and our energy performance indicator. And also we need to integrate the risk management approach in order to address the uncertainties like the energy price volatility or supply interruptions. And finally, we have the actions plans. Next is do. In do stage, this involves the resource allocations and establishing the necessary awareness. This will ensure that all personnel related to our significant energy use are competent through appropriate training, and also will include controls and design and procurement. And in this stage, we consider energy performance in the design of new or renovated facilities and to set criteria for energy-related procurement. Once the system is operating, we move to check. This is the evidence-based reality check for the environmental management system. Here we establish our measuring and monitoring plan, conducting our internal audits, and perform the compliance evaluation, identify the non-conformities. Then we move to the act. In the act, this is centered on the management review. In this management review, it's not a simple report session. It's a strategic decision-making forum, okay, where we review several inputs, such as the energy performance indicators, the audit results, any changes may be happened in our system, the adequacy of the system, in order to have specific outputs such as updating for the objectives and targets, any changes to our energy policies, and to move into the management review process itself, where we have several inputs and we expect several outputs. For example, from the audit results and the compliance status, we expect output related to how much changes do we need in our objectives and targets. For the adequacy of resources, the output we expect is decisions related to how much
Dr. Mohammed, you are muted. You hear me, doctor?
Yes, yes. Can you hear me? Can you hear me right now?
Yeah, yes, clear,
Sorry,
clear,
this
doctor.
disruption.
Clear, doctor.
Okay, so now everything is fine, right?
Yes,
The
yes,
voice is
clear,
clear now.
very clear. Very clear, doctor. Yes.
Okay. So, I and one, we can conclude it. Simple words that say ISO will transfer from a cost center or from operational cost into source for sustainable and competitive advantage. And this will drive us to the last section of our webinar today, related to the ISO 14064. Actually, this standard was developed to urge need for consistent and credible GHG management. And here I want to be implementing this framework is not merely a compliance exercise, it is a strategic move. Why? Because this standard is the foundation for enhanced environmental integrity, improved risk management, and on the same time, strengthened stakeholder trust. Now, in a world of greenwashing accusation, this standard is the primary mechanism for proving your commitment towards climate change is real. It's important to know that ISO 14064 is not a standalone document. It is a central component of the broader 14060 family of standards. The core purpose of this entire family is to provide clarity and consistency for quantifying, monitoring, reporting, and most importantly, verifying GHG emissions and removal. ISO 14064 creates a common, credible language for GHG accounting, which is essential for supporting the low carbon economy. To achieve this standard is broken down into three-part structures. The design is what ensures a comprehensive and integrated approach of GHG management, connecting the different levels of accounting to form a single project all the way up to the entire organization. Here we have three parts. The ISO 14064 part 1. This is for the corporate level footprint, and it provides the requirements for designing and reporting the entire organization level GHG inventory. This is the what is our total impact on the climate change. And here we have the second, ISO 14064 part 2. This is for the project level. This is how to quantify reduction, focusing on specific projects designed to reduce emissions, like efficiency upgrade or carbon capture plant. It's about measuring the project's performance against a baseline. And third, we have the ISO 14064 part 3. It is for the verification and validation. And here, this standard introduces the proof, since it provides the requirements for independent third-party verification or third-party verifier will come and will provide assurance that our claims for part 1 or part 2 are accurate, complete, and credible. Okay. So here, let's dive into the strategic imperative. Here we have two primary strategic drivers. The first one is to enhance credibility, since adhering to this standard is the backbone for auditable investment grade data. And with with new disclosure rules from different regulatory bodies such as the European Directive. This is what stakeholder expects. It what builds crucial trust in our climate disclosure. Second, here, you cannot manage what you cannot measure. This standard actually helps us to build for improvement, since it creates a systematic methodology to establish a historical baseline and to set meaningful reduction targets and truly measure our progress over time. So here, this standard turns reactive reporting into proactive management strategy. This framework is precisely what organizations need to navigate a complex web of modern demands. For corporate decisions, this standard actually pinpoints high emission processes, which often represents systematic inefficient in energy and resource use. For risk management, it gives us a systematic way to identify and manage our climate-related risks, from financial to regulatory vulnerabilities to supply chain disruptions. For the market demands, it provides credible, verified, required data for sustainability reports and for participation in carbon markets. And of course, for regulatory programs, this future proves our data architecture. Since now mandatory GHG reporting becomes the global norm, this standard ensures that we are prepared and our data is defensible. Let's have a quick look for the implementation of ISO systems. First of all, we need to identify what's called the organizational boundaries and the reporting boundaries. And in the organizational boundaries, the key decisions that will be taken is what is the approach that we will take, control approach, where in this approach, the organization is committed to 100% of the emissions or the equity share, where and in this approach, the organization was only committed according to the equity share. And then we have the reporting boundaries, and in the reporting boundaries, here we identify what's called the SSR, the GHG source sinks and reservoirs, and to classify the boundaries into the reporting into scope 1 and scope 2 and scope 3 emission. After that, we will start our journey into quantifying the emissions, where we will start to identify the sources and to set the quantification approach and to calculate the GHG emissions and also establishing the base year. Then comes the reporting, and in the reporting, here the report will contain a clear description for the reporting organization and the boundaries and the results from the quantification for the direct and indirect emissions. And also we will describe our baseline and why did we choose this baseline. For the part 3, here comes the rule of verification. And here it is the core mechanism that will lead us to a more credible of our process. Verification, it is the independent, systematic, and evidence-based process with a clear purpose is to provide an objective assessment of our GHG efforts. Verification is what transforms our metrics into information that we can confidently share with our investors, regulators, and other stakeholders. Actually, without verification, our efforts is just a claim, but with verification, it becomes a effect. So in this journey, we discussed the meaning of decarbonization, the different tiers for achieving decarbonization through a logic and strategic view. And also we discussed the different ways for standardizing the efforts that we will make in order to decarbonize our processes through implementing two main management standards, starting from the ISO 50001 and then the ISO 14064. Through this chain, we can say that we are on the right track in order to decarbonize our process and to make positive impacts towards the climate change. Thank you for your patience, and thank you for your listening. And I will be so glad to take your comments and questions. Thank you, Yousef.
Thank you so much, Dr. Mohamed, for this very precious, very informative information. Actually, very, very important topic to whom he's very interested. Actually, it's all HSE professionals or environmentalists or everyone working in this field as in environment. He shall learn actually sustainability, ESG, GHG, decarbonization, a lot of concepts. That is really important. We really appreciate Dr. Mohamed for your effort and information. And go ahead, Mr. Abu Khaled. General Yousef, you have a comment? Yes.
Well, I have a question.
Yes, go ahead.
Thank you so much, Dr. Mohamed, for this informative presentation. It was really enrich my knowledge about this one. But I have a question, if you allow me. Okay, what are the challenges that faces the company from implementing this decarbonization process?
Okay, thank you, Engineer Yousef, for this question. Actually, there are a lot of challenges, but I will focus on one of the most significant challenges in implementing decarbonization. I would call it the knowledge gap. What is the meaning of knowledge gap? Knowledge gap, we have now a lot of information come from the reports, the publications, from the scientific papers and scientific reports released from the climate-related organizations, okay? And we have a lot of people that want to implement these decarbonization policies, practices, procedures, okay? But there is a gap between this point and, or gap between supply and demand, let's say. And I believe through continuous learning, continuous capacity building, an event like what we have today is a mean for closing this gap between the knowledge and the This is, from my point of view, one of the most crucial and first priority challenge that we need to address and tackle. How we can close these gaps through more courses, through more certificates, through more momentum in order to enrich and to increase the knowledge and awareness related to decarbonization.
Muted, Abu Salis.
Yeah, I'm sorry. I mean, is there any steps or roadmap that companies need to do or to adopt in order to?
Yes. Here, actually, I prefer the logic, let's say, logic steps or logic roadmap in order to implement decarbonization. Let's first focus on what's called the low-hanging fruits, okay, or low-cost, no-cost actions, because these actions, starting from repairing leaks, whatever leaks in different forms of energy, like repairing methane leaks, compressed air leaks, improving and repairing the insulation, making some sort of optimization in the process. All these actions, or we called it the low-hanging fruits or low-cost, no-cost actions, will encourage management to move forward with the decarbonization process, because you cannot convince the management to go into mega projects like the carbon capture, utilization, and storage without first showing the management the results that could be achieved from the simple and the low cost, no cost actions in order to improve the energy efficiency and the reduction of carbon footprint. The second block, also organizations need to address proactively all the regulatory requirements that the organization may encounter in the future in order to reduce, which could enforce the organizations to reduce their carbon footprints. Now, we live in an interconnected world. A regulatory requirement may release in Europe, could affect us here in the Middle East, and actually this is happening right now with the issuance of CBAM, or carbon border adjustment mechanisms, which enforces several industries to calculate the carbon footprint and not to cross specific thresholds of carbon emissions. So organizations need to address all these requirements, and then to have a short, medium, long term for carbon reduction based on the different tiers that we discussed during the webinar. Tier 1, energy efficiency measures. Tier 2, electrification and increase the use of renewable energy integration with different means of renewable energy. And third, with the advanced carbon management like carbon capture and the utilization, increase the utilization of biomass and the carbon capture of biomass. Through this long roadmap, organizations can be on the right track. And also, I would like here to pinpoint that all these efforts must come in standardized form. It means it must be through a standardized framework from ISO 50001 of energy management system, supported by the ISO 14064, which will quantify all these efforts into single number of CO2 reduction, and through verification, organizations can ensure they are on the right track.
Muted.
Thank you so much. Thank you so much.
Thank you, Dr. Mohammed, again. Wallah, thank you so much for your information. Very informative webinar. And I would like to thank everyone. Anyone have a question? If you want to have a question, you can raise his hand or ask in the chat line. I appreciate everyone spend his time to join our webinar, and on behalf of Garuh International, we appreciate your attendance. We thank you we cannot say enough thanks words to Dr. Mohammed for his precious time to joining us in this webinar. And inshallah, we have more webinars coming ahead for many topics. Also, you can write down, there is a survey I posted here, link. Just write down fill it and write your comments. If you have any questions, you can write, you can suggest also to us. So in the end, we are happy that we saw you all. I can see some questions coming ahead. Mr. Hakim is writing, some others writing here in the chat. So inshallah, in future, we have a lot of webinars in the same many important pillars for sustainability and other topics as well. And also we have a plan that is our objective to enhance and sharing the knowledge along all our professional colleagues in this field. You are welcome, Mr. Hakim, and welcome all of you. And now, if you have any questions, just ask. Otherwise, we will now the time of we say goodbye to you, and we'll soon to see you soon, inshallah, for the next webinars, inshallah. Thank you, Dr. Mohammed. Thank you, Abu Khalid, Mr. Yousef Alrasheedi. Thank you for this sponsoring this webinar, and inshallah, see you soon in the next webinars, inshallah. Thank you so much, and see you. Thank you so much.
Thank you.
Thank you so much.
Thank you.
Thank
See
you.
you all.
Thank you. See you. Assalamu alaikum. أبو خالد سمعني؟ Just a moment. I will just everyone's signing out, or they are filling the survey. We have a survey that I mentioned already in the chat.
Abu Khalid, thank you.
Mr. Bazo, thank you so much. Thank you so much for attending. Thank you so much.
مشكورة.
Wish you the best, brother.
Thank you, sir. After a long time.
Yeah.
Thank you, Mr. Bazo.
مشكور.
مشكور Mr. Bazo. Thank you.